Have you ever looked at a digital image and wished you could perfectly outline every distinct object, with crisp, thin lines that truly capture their boundaries? Achieving such precision in computer vision often relies on a clever technique. Non-Maximum Suppression, or NMS, is a vital step in the Canny edge detector algorithm. Its primary role is to refine the initially broad and blurry edge candidates, thinning them down to clean, 1-pixel-wide lines. This process is essential because raw gradient calculations, which measure changes in image intensity, often produce thick bands of pixels, all indicating the presence of an edge. Without non-maximum suppression, these edges would appear chunky and imprecise. The core idea behind NMS is to identify the pixel within such a band that truly represents the local peak of the edge strength. It achieves this by comparing a pixel's gradient magnitude to those of its immediate neighbors, but specifically only the neighbors that lie along the direction perpendicular to the edge itself. To perform this, the Canny algorithm first calculates the gradient magnitude and direction for every single pixel in the image. Next, it quantizes these gradient directions into a few primary angles, typically for 0, 45, 90, and 135 degrees. For each pixel, the algorithm then checks if its gradient magnitude is the largest compared to the two pixels directly adjacent to it in the determined quantized gradient direction. If its magnitude is not the maximum, that pixel's magnitude is suppressed, effectively setting its value to 0. This suppression step filters out all but the strongest local edge responses. This meticulous directional comparison is what gives Canny its superior edge localization. By ensuring that only the absolute peak of the gradient along the edge's profile is retained, non-maximum suppression drastically reduces spurious edge responses and significantly sharpens the resulting edge map. It is the critical bridge between detecting potential edges and presenting them as clearly defined boundaries, ready for the final hysteresis thresholding step. Ultimately, non-maximum suppression provides the Canny edge detector with its characteristic precision, delivering a highly refined and unambiguous set of edges. This sharp output is invaluable for subsequent image analysis tasks, allowing computer vision systems to accurately identify shapes, objects, and structures within complex visual data.